Alright, starting lesson 7.1a, linear and nonlinear systems of equations. Alright, a system of equations just means you're working with more than one system. Alright, for example 1, determine whether the ordered pair 2, -9 is a solution to the system. Okay, so in order for the ordered pair to be a solution, we plug the x and y values into both equations. And if the equality works out to be true for both, then it is a solution to the system. Alright, let's plug it into the first equation. We have 4 times 2 squared plus -9 is equal to 3. So I get 4 times 4 minus 9 equals 3. 16 minus 9 equals 3. I get 7 equals 3. And that is false. So if it doesn't work for one of the equations, just one of them, then it's not a solution to the system. So your answer is no. It has to work for both. Alright, 3 scenarios when you're solving a system. Alright, you could end up with one or more solutions. Here's an example. You could end up with infinitely many solutions, and that's the case when you end up with an equality. That's true. Or you could end up with no solution, where you end up with an equality. That's not true. All right, example 2, solve the system of linear equations by substitution. Okay, so let's isolate one of the variables for one of the equations. So here I'll just add y over here, and I get x equals y. All right, and then I plug in, let's see, x for y here. Replace that with x. All right, and the other equation, don't put it back in the same equation. That's not going to help you at all. All right, then I get 2x equals 6, divide by 2, x equals 3. All right, that's one piece of information. Now all I do is plug it into any equation and solve for y. So 3 equals y. Okay, so my answer is 3, 3. Done. Let's do another example. All right, solve the non-linear system of equations by substitution. Okay, let's see. I'm going to add 2x here, and then I'll isolate y. All right, now let's substitute this in for y. Alright, so I get x squared plus 3x minus 2x plus 5 equals 1. Okay, now I intentionally made a little error here, and it's one that I often see students make. Don't forget to put parentheses around the 2x plus 5, because you have to distribute that negative, and if you don't, everything gets thrown off. Watch out for that. Alright, so distributing that negative, I have this. Alright, and now I'm going to simplify. I'll subtract 1 over. Okay. And then I have 1 on top, -6 on the bottom. The two numbers that add up to 1 are 3 and -2, and they multiply to give you -6. Alright, so this factors into x plus 3 times x minus 2, and that equals 0. X plus 3 is equal to 0, and x minus 2 is equal to 0. So x is equal to -3, x is equal to 2. Oops, not -2. Positive 2. Yeah, watch out for that as well. Many students make that mistake. Alright, so I have these two values, and all I'm going to do is plug it back into this equation up here. So I get y is equal to 2 times -3 plus 5, -6 plus 5. Y is equal to -1. All right, and I have -3 and -1. That's one of my answers. And then I have y is equal to 2 times 2 plus 5. Let's get y is equal to 4 plus 5, y is equal to 9. All right, so my other point is 2, 9. So there's my two solutions to this system. Let's do another example. Okay, here I can isolate, I'm going to isolate y once again. I have to divide by -1. So I get y is equal to 2x plus 3. All right, now let's substitute this into the other equation. So I get 2x squared plus 4x minus 2x plus 3 squared. Okay, there's a bit of work involved in this. It's not that bad though. So I'm just going to take my time, work everything out step by step. I'm going to use brackets here. I have to expand this. Okay, then I have to FOIL. So I end up with 4x squared, and then I have plus 6x plus 6x plus 9. All right, then I have 2x squared plus 4x minus 4x squared plus 12x plus 9. All right, now I have to distribute that negative. Be careful with that. Oops. Then I have negative 2x squared. I'm going to combine like terms. Minus 8x. Alright, minus 9 equals 0. Alright, so let's see if we could factor this. We need to find two numbers that add up to -8. Multiply to give us 18. Alright, and there aren't two whole numbers that work. So what do you do in this case? You can't factor this. Well, maybe the quadratic formula will work, because that'll give you whole number solutions as well as non-whole number solutions. So let's figure out my A is -2, B is -8, and C is -9. Alright, so x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, and I have 8 plus minus 64 minus 72 over -4. Then I get 8 plus minus -8 over -4. Now we're taking the square root of a negative number, so right away we know there is no real solution for this problem. And we're done. Alright, last example. Okay, first we have to isolate the y. Alright, solve a system by graphing using a TI calculator. So input both of these on your TI calculator, hit y equals at the top left. Okay, when you graph, alright, you could hit graph and standard. And then we have these two graphs. Alright, it should look like that on your screen. This is y equals -x plus 1. And this is y equals natural log of x. Okay. Now if you hit second trace or second calc on your calculator, the top middle, alright, then it's going to give you the option to find the intersection point, which is option 5. Alright, so you hit that, and you're going to get a star flickering on one of the graphs. Hit enter, and then another star should appear on the other graph, and that'll flicker. Hit enter, and then you hit enter one more time, and it's going to hone in on where those graphs intersect. And it should show you the values at the bottom, left and right. X equals 1, y equals 0. All right, so your solution is 1, 0. It's as simple as that. All right, really cool feature on the calculator. If you need any help with the calculator, please make sure to ask. If you need any help at all, please make sure to ask. All right, begin the assignment.